Okay, ladies, I'm going to do one last section here to wrap up Math 115. Section 11.7 is going to have us applying the normal distribution to everyday problems. So I'm going to work out several problems out of our textbook before we call it quits. Right, and you're always welcome to look over this last section, 11.7. I'm going to target a couple of problems that I want to demonstrate. These problems will make use of the calculator that we have on our Canvas course site, both the normal calculator and the inverse norm calculator. Okay, I'm going to try to do problem number 5 first. It says the average hourly wage for all workers in the area of leisure and hospitality in 2021 was $19.15, according to the Bureau of Labor Statistics. If wages for this sector are normally distributed with a standard deviation of $3.15, find these probabilities for a randomly selected worker in the leisure and hospitality sector. Question A, they want you to find the probability that their earnings are more than $20 per hour. So for question A here, for problem number 5, they want us to compute the probability that someone randomly selected in this sector has a wage that is greater than $20 per hour. Symbolically, that is going to be this probability. Drawing a picture of the area that corresponds to this probability. Here is the normal distribution of the hourly wages. And they indicate to us in this problem that the mean hourly wage is $19.15. So $20 is going to be a little bit above that. And this probability that they want us to find is really equal to this area in the upper tail of the normal distribution. To find this area or this probability, we're going to use our normal calculator, where our mean of this distribution is $19.15 and the standard deviation is $3.15. Notice for this interval, the lower end point of our interval is 20 and the upper end point is positive infinity, which is going to be entered in as 1e to the 99th power. Okay, let's take this information to our calculator, which is at our Canvas course site. On our main dashboard page, we have the link to the normal calculator. Let's click on it. Now the lower bound of this interval is 20. The upper bound is 1e99. The mean of this distribution is $19.15. And the standard deviation is $3.15. Let's calculate the area. And there we go. This is our area, 0.3936. Again, let me show you what I typed into this calculator. Again, we accessed this calculator from our Canvas course site and clicked on the normal calculator link. And then for the lower bound, I typed in $20. Upper bound is 1e to the 99th power. The mean of this distribution is $19.15. And the standard deviation is $3.15. Then I just clicked on calculate. And we get our area right here, which is 0.3936. Therefore, there's your probability. So the probability of randomly selecting somebody in the leisure and hospitality sector and having their wage be more than $20 an hour would be about a 39% chance. For question B, They want us to compute the probability that a randomly selected person in this sector earns less than $13 an hour. This will be the probability we're trying to find. Graphically, that probability would be remember, the mean again is $19.15. So this would be less than $13, which is going to be down here. And we're trying to find this lower tail area here. This lower tail area is really equal to this probability. So again, we take to our normal calculator mean of $19.15, a standard deviation of $3.15. And our lower bound of this interval is negative infinity, which is going to be negative 1E99. The upper bound is $13. The mean and standard deviation are these values right here. So let's go to our calculator, our normal calculator. And let's type in our lower bound, which is negative infinity, which is negative 1E99. The upper bound is $13. The mean is $19.15. Standard deviation again is $3.15. Click on calculate, and you have your probability. And there's your answer, 0.0254. And so that would be the probability of randomly selecting somebody in the leisure and hospitality sector and having their hourly income be less than $13. There'd be about a 2.5% chance of that happening. This probability is equal to this area. And we're done with that question, number 5. All right, let's look at problem like number 9. A survey found that people keep their televisions an average of 4.8 years. The standard deviation is 0.89 years. If a person decides to buy a new TV, find the probability that they have owned the old one for the given amount of time. Assume the random variable is normally distributed. So in A was the probability that a person, before they bought a new TV, kept their old one for less than 2.5 years. So that's the question we're going to answer first, 9A. The probability that X is less than 2.5 years. That's how we represent it symbolically. And that is going to represent this area underneath this normal distribution. Where the mean time people keep their old TVs is on average about 4.8 years. And the standard deviation time is equal to 0.89 years. So less than 2.5 years would have 2.5 be down here on the horizontal axis. And this probability is really equal to this area. So we're trying to find this area underneath this normal distribution with this mean and this standard deviation. This area right here is equal to this probability. So our lower endpoint of this interval is going to be negative infinity, which is going to be negative 1e to the 99th power. The upper endpoint is 2.5. Let's take this information to our normal calculator at our course website. All right, so therefore the lower bound is going to be negative infinity. We're good on that. The upper bound is going to be 2.5. The mean is going to be 4.8. And the standard deviation is 0.89. We're now going to calculate this area. And we're done. And there is the area, 0.0049. And therefore, the probability that someone randomly selected that keeps their TV less than their old TV less than 2.5 years would be about 0.49% chance. That's the answer to question A. This probability is equal to this area right here. Now for 9B, what's the probability that somebody keeps their old TV between 3 and 4 years before buying a new one? Symbolically, this is going to be represented as X greater than 3 and less than 4. Graphically, the mean is equal to 4.8 years. Standard deviation is 0.89. Between 3 and 4 years. So therefore, this probability that we want to find is equal to this area here underneath this normal distribution curve, where the mean is 4.88 years and the standard deviation is 0.89 years. So therefore, our lower endpoint of this interval is 3, the upper endpoint is 4. Taking this information to our normal calculator, we'll compute that area or that probability. Therefore, the lower endpoint is 3. Upper endpoint is 4. The mean of this distribution is 4.8 and the standard deviation is 0.89. Click on calculate and boom, there you go. This would be that area or that probability. And so therefore, there's about a 16% chance that we will randomly select somebody, and that somebody will keep their old TV for about 3 to 4 years before buying a new one. This probability is equal to this area right here between 3 and 4. Finally, for part C of this question, they want us to compute the probability that somebody keeps their TV for more than 4.2 years. That is going to be equal symbolically to this probability here. And graphically, that is going to be this area. Greater than 4.2 is going to be like right here. It's going to be this area here. So this area is really equal to this probability. So our lower endpoint of this interval is going to be 4.2, and the upper endpoint is positive infinity, which is 1e99 power. And keep in mind the standard deviation of this normal distribution is 0.89. Taking this information to our normal calculator, we can compute that area or that probability. So our lower endpoint here is 4.2. Upper endpoint is 1e99. The mean of this distribution is 4.8 and the standard deviation is 0.89. Calculate. And boom, there's your area or probability, 0.7499. And so we are done. Hence, the probability that someone keeps their TV for more than 4.2 years is about a 75% chance. This probability is equal to this area here. All right, now I'm going to go to problem 24, and number 24 is going to ask us to find a percentile value. Up to this point, we've just been finding probabilities or areas. But what if we're given the area and we want to find a percentile value? Well, that's represented in problem 24. It says refer to exercise 9. If you buy a TV for your dorm and keep it for your 4 years of school, then sell it. What percentile does that put you in? In other words, what percent of people, okay, keep their old TV for less than 4 years? That's what they're asking us for. We're trying to compute a percentile value. So for number 24, we're still using the same normal distribution that we used in problem 9, where the mean is 4.8 years and the standard deviation is 0.89. They want to find what percentile 4 years is. So 4 years is going to be less than 4.8 years. I'll put 4 years down here. So they want us to now find this area here. Well, let's see here. Yeah, they want us to, okay. They want us to find what percentile 4 years is. So I sit corrected. We need to use our normal calculator to answer this question, the same one we used for all the other problems up to this point. So our lower end point is negative infinity, which is negative 1e99. Upper end point is 4. The standard deviation, the mean of the distribution is 4.8. The standard deviation is 0.89. Let's take this to the normal calculator. All right, the lower bound is going to be negative infinity, which is negative 1e99. The upper bound, the upper bound is 4. Standard mean is 4.8. Standard deviation is 0.89. And now we just calculate here, and we find that it's like 0.1844. That's the area. So what we just discovered is the probability of somebody that keeps their TV for less than 4 years is equal to 0.1844. This means that 4 years of ownership of an old TV is the 18th percentile, about the 18.4th percentile. In other words, we would expect about 18.4% of all people to keep their old TV for less than 4.2 years, for less than 4 years. Excuse me. That's how you do a problem like number 24 there. All right, suppose I asked ourselves this question for this same distribution, this TV distribution. What would be the 95th percentile number of years that a person would keep their old TV before buying a new one? What would be the 95th percentile of the number of years that somebody would keep their old TV before purchasing a new one? Well, to answer that question, graphically means that we want the area below this unknown percentile value here to be 95%, called the 95th percentile. So we want all this area here to be 95% of the area of the entire curve. So now we're given the area, but we're being asked to find the percentile value below of which is 95% of the area of this curve, where again, the mean is equal to 4.8 years, and the standard deviation is equal to 0.89 years. So we're trying to find, we're trying to find this percentile value. Okay. All right. Now, to find this percentile value, we're gonna have to use the inverse norm calculator on our calculator, on our to handle this problem. And the inverse norm calculator link is found on our Canvas course site. So the area to the left of this unknown percentile is 95%, 0.95. Let's go get the inverse norm calculator. Back on our main dashboard of our Canvas course site, we have an inverse norm calculator for finding percentiles. Let's click on that. All right, now the area that is to the left of the unknown percentile we want to find is 95%, 0.95. Because we know this is the 95th percentile, we're just trying to find it. The mean of this distribution is 4.8 and the standard deviation is 0.89. Now let's calculate and find our 95th percentile. And our 95th percentile is 6.26 years. There's your answer. And so, ladies and gentlemen, we have our answer there. We therefore know that 95% of all people that own a TV keep their old TV for less than 6.26 years before purchasing a new one. For that reason, we say 6.26 years is the 95th percentile. All right, suppose I want to find the 5th percentile. Well, graphically now, we know the area to the left of this unknown percentile, this 5th percentile, is going to be 5%. So this is going to be 5%, this area down here. We want to find this percentile value, this 5th percentile. So we go to our inverse norm calculator and type in the area to the left of this unknown value is 5%. The mean is 4.8, standard deviation is 0.89. So let's go to our inverse norm calculator. The area to the left is 0.05. That's the 5th percentile. The mean and standard deviation remain the same. Click on calculate and boom, you got your answer, 3.34. In other words, 3.34 years is the 5th percentile, meaning that only 5% of TV owners keep their old television for less than 3.34 years before purchasing a new one. This is called your 5th percentile. All right, ladies and gentlemen, that's going to wrap it up. I've shown you one of each. I've shown you several of each type of problem that you're going to be responsible for in section 11.7. Just basically extending our standard normal distribution from 11.6 to be any normal distribution in 11.7. The only difference is the mean and standard deviation is no longer exactly 0 and 1 like it always was in 11.6 when we were looking at that special normal distribution called the standard normal probability distribution known as the Z distribution. In section 11.7, the normal distributions could have any mean and any standard deviation now. But you still use the same calculators to answer the same type of questions that we answered in 11.6. Whether we're trying to compute an area, we use the normal calculator, or trying to find an unknown percentile value, we would use the inverse norm calculator. Well, that's going to wrap it up for Math 115. I hope you enjoyed the course. It was a pleasure having you for this particular math section. I do wish you all the best in your future academic endeavors, and I hope that you find what you're looking for in life academically and as far as your career is concerned. All right, if you have any questions or concerns, please do drop me an email, as I will be checking my emails very frequently. Just make sure that we also finish all the remaining work by the deadlines as specified by the schedule.